A very good evening to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on resultant of general force system. It's a type 1 problem to find the magnitude, direction and location of the resultant force with respect to a point in the system. Let's see how the question statement goes. A system of forces acting on a bell crank lever is as shown in the figure. Determine the magnitude, direction and the point of application of the resultant with respect to point O. Now friends, why this is a general force system? First of all, as you can see, there are total 4 forces acting in the system: 500 Newton, 1000 Newton, 1200 Newton, 700 Newton. Neither they are acting at the common point, that is same point. So that's why it's not a concurrent force system, nor all of them are parallel to each other. That is why it's not a parallel force system. Hence, it is a general force system. Now let us go for the free body diagram of it. Now we can write it down one by one. What are we supposed to find? So I can write it over here. To find is magnitude of resultant, that is R, direction of resultant, that is theta, as well as the location, that is at what distance is the resultant with respect to point O, that is small d. Now step 1 will be the free body diagram, as you all have seen. So we will be drawing the free body diagram now. Let's go ahead with the free body diagram. It's a bell crank lever, my dear friends. As you can see it over here. Like this. Now, one by one, let's show how the forces are acting on the bell crank lever. So it's a 500 Newton force acting at an angle of 60 degrees. It's a 1000 Newton force acting vertically downwards. It's a 1200 Newton force again acting vertically downwards, and it's a 700 Newton force over here. So friends, let us see at what distances they are acting. All the dimensions or distances whatever are given are in millimeters. So only I would like to write the values. It is 150 mm over here. It's 150 mm again over here. Even from this, here and here, I can show the distances. It is 150 and it is 150 again. So this is the point O from where the resultant is supposed to be located. Now let's go for step number 2 and for the solution of the problem. So I'll be writing solution step 2. Now friends, we are supposed to find out algebraic sum of all the forces in x direction towards right will be considered as positive. Just before that, since there are total 4 forces and only one is an inclined force, that's why we will be resolving that particular one force only, that is 500 Newton force. So it will be 500 cos of 60 and this will be 500 sin of 60. Rest all the forces need not to resolve them. So let's write down the equation. Here it is 500 cos of 60 minus 700 is equal to. Let's go for the calculation of it, my dear friends. So it's over here 500 cos of 60 bracket close minus 700. So the value comes out to minus 450. That means it will be minus 450. So how I can write this? Summation Fx is equal to 450 Newton towards left hand side. Now step number 3. Step number 3 is nothing but we will be writing summation of forces in y direction acting in upward sense as positive. So here it is. The equation goes as minus 500 sin of 60 minus 1000 minus 1200. So here it is. Let's go for the calculation of it. So it will be minus 500 sine of 60 minus 1000 and minus 1200. So it's done. So minus 2633.012. Over here we can write it minus 2633.012. Therefore, summation Fy is equal to 2633.012 Newton acting vertically downwards. Now, step number 4 is the magnitude of R. Step 4 is nothing but R is equal to root of summation of Fx square plus summation of Fy square. So friends, over here I can show it like this. It will be 450 square plus 2633.012 square. So once we are done, let's go for the calculation part of it. So over here it is squaring this plus 450 square is equal to square root of it, square root of the answer, 2671.189. So here it is 2671.189 Newton. Of course, my dear friends, as you can see, summation Fx is acting towards left, summation Fy acting vertically downwards. That is why resultant will be acting in third quadrant. So therefore, R is equal to like this. Now step number 5. Step 5 is nothing but finding out theta. Now that is direction. Theta is equal to tan inverse of modulus of summation Fy divided by summation Fx. Therefore, theta is equal to tan inverse of, since we are taking in magnitude, that is why only values are expected to be taken, that is the positive values. No sign of it is expected to be taken. Divided by 450. As you can see, therefore, theta is equal to, let's go back to the calculation, tan inverse of 2633.012 divided by 450 is equal to 80.301 degrees. I can write it over here. So the value is 80.301 degrees. Now next step, the last step, that is nothing but the location of resultant. Step number 6. I can write it over here. Step 6, location of resultant. So it will be, we are supposed to assume that let the resultant be located, it may be located to the right of O or to the left of O. Let us just start with an assumption that the resultant is located to the right hand side of O. Let R be located at perpendicular distance small d to the right of O. Now, since we have assumed it, I'll be just showing it on the diagram. Let this particular R that we have assumed, it will be located somewhat like this to the right of O. This is R. And if I show it over here, the angle of R is this theta, which is nothing but 80.301 degrees. So now, if we will be showing the distance, what is the distance small d? This will be the perpendicular distance small d. This is the distance that I have shown. So now, how to find out that d? So by Varignon's theorem, Algebraic sum of moment of all the forces about a point is equal to moment of resultant about the same point acting in clockwise sense is positive. Friends, many of the teachers are considering towards anti-clockwise sense as positive. I have considered in clockwise sense as positive. It doesn't make a difference. Final answers are going to be correct for both of them. So now let me go ahead with this. Friends, while we are calculating the moment of forces about a point, we need to understand first of all how many forces are going to get considered about point O. First of all, only 500 sin 60 will be considered, 1000 will be considered, 1200 and 700. Why not 500 cos 60 is going to get considered? I'll be showing it over here, dear friends. This is resolved. This at the tail, it can be resolved at the tip as well, on the arrow as well. So actually it is resolved over here and 500 sin 60 is resolved over here. Friends, as you can see, 500 cos 60 is acting at point O. That is why it doesn't has any distance with point O. That is why it won't be considered. Its moment will directly becoming 0. So now I will be writing the equation one by one. If I sit at point O with respect to O, 500 sin 60 is causing the body to rotate in anti-clockwise sense. So how we can see that? We can just keep a finger over there and with the help of the thumb try to rotate the body. So it will be rotating in anti-clockwise. That's why minus 500 sin 60 into the entire perpendicular distance is 300. Again minus 1000 into 150. Now plus 1200. Friends, this 1200, as you can see, it will be forming a right angled triangle. This angle is 60 degree already given to us in the problem. Already you can see the angle of 60 degree of the bell crank lever is there with us in the problem. You can just check it. Yes, it is given. So that's why what I can say is, for this right angled triangle that is formed, this distance will be nothing but the adjacent one. So now I need to find, in a broader aspect, I need to find this adjacent distance. I will write it over here, ADJ, adjacent. Friends, this distance will be the perpendicular distance for 1200 Newton force. How do we get that? In this right angle triangle, cos 60 is adjacent upon hypotenuse. Just for our calculation sake, I'll be showing it over here. I can just write it down over here. Cos 60 is equal to adjacent upon hypotenuse, that is 150. Therefore, adjacent is equal to 150 cos of 60. So plus 1200 into, it will be 150 cos of 60. Last but not the least, my dear friends, this 700 Newton force, it's a straight dead horizontal force. For this force with respect to O, many of the people get confused that the perpendicular distance is this 300, but no, my dear friends, it is not this 300. Why? Because for a horizontal force with respect to a point, there has to be a dead vertical distance, which is nothing but, if by principle of transmissibility I transfer this force over here, I extend and line, dead straight line over here, this is the vertical distance that we want. Actually, this distance is nothing but the particular distance that we can consider as the opposite distance of this right angle triangle, which is this one. So friends, again for this I can form sine 60 is equal to opposite upon hypotenuse. So this is the opposite side that I want. So for this it will be minus, because it will be causing the body to rotate in anti-clockwise sense, minus 700 into 300 sine of 60 is equal to r. R is causing the body to rotate in clockwise sense, my dear friends. So that is why 2671.189 into small d. Therefore d is equal to, now I will be calculating this particular equation. So now over here it is minus 500 sine 60 minus 500 sine of 60 into 300 minus 1000 into 150 plus 1200 into 150 cos of 60, last but not the least, minus 700 into 300 sine of 60. Okay, so the value comes out to be negative divided by the value of resultant. And what is that? The value of resultant, my dear friends, it is 2671.189. So it is 2671.189. So here it is, minus 139.177. So friends, since the value comes out to be negative, minus 139.177. So now what I can do is, over here straight away I can write it over here like this. In this I'll be raising it. So finally, therefore D is equal to 139.177 D is equal to 139.177 to the left of O. Our assumption went wrong about the location, which was to the left actually rather than right. So finally, how can we write this? Therefore, R is equal to 2671.189 Newton at theta is equal to 80.301 degrees towards third quadrant, located at a perpendicular distance small d is equal to 139.177 mm. Don't forget to write down the units, to the left of O. Okay, once we are done with this, my dear friends, only a part that I would like to tell is just a change, that what we could do is, just I'll erase this part and I'll show a diagram that is expected to be drawn. So it is nothing but I'll be drawing a bell crank over here, same way as I have drawn it initially. So it's over here like this, and with respect to O, if you can see the resultant R, which was located to the right, it is actually located now towards the left. This is R located at the angle theta, and the distance D that will be shown over here. This is the perpendicular distance D. This is the way how the problem gets completed, and the distribution of marks. If it comes for 6 marks in the paper, so 1 mark over here, summation fx along with the value, 1 mark for summation fy along with the value, 1 mark for r, 1 mark for theta, 1 mark for the correct value of d, and finally 1 mark for the both these joint FBD. So that is how 6 marks are given. And if at all it comes for 8 marks, so 1.5 marks for this, 1.5 mark for this, 1.5 mark for this, again 1.5 mark for theta. This is still here 6 marks. Now 1 mark again will be for this, and half mark for the FBDs. So friends, this is the way how the problem will get over. So please do like, subscribe and share this video. Thank you everyone.